I'm vandenEnden, and this is my project for Professor Ellery's Space Robotics. This is my automated Lego sorter, which I constructed out of various components, and then trained an object detector and classifier using YOLOv8 to autonomously sort. So as we go through here, first of all, this power distribution switch using a perforated board will enable power to our system. Then we go to our trough where various Lego elements can be loaded, and they're basically drawn up with a conveyor belt. There is a flap on the bottom so that the cleats, when they go over, will not allow for pieces to fall underneath. When they go up over top of the conveyor belt, they are deposited into a trough, and this allows us to actually parse out and individually classify each element through a vibrating motor here, and that's going to vibrate the whole trough. These are all connected by spring, so the spring makes sure that it's actually able to transfer the vibrations throughout the entire trough. After we go from that, we move to our conveyor. There's a number of channels which allow the pieces, no matter what size or shape, to be centered in front of the camera. Now the camera here, this is the brains of the operation, connects to a Raspberry Pi 4B running Python code, which utilizes both the YOLOv8 classifier model I mentioned earlier, as well as TensorFlow, in order to bound and classify the elements, as we'll actually see in a second as these pieces are deposited onto the conveyor. We'll run past the camera and classify them. So as we see here, goes into number 2, so as number 4. This model specifically is only trained on 4 different elements. So for example, the 1x1, 1x2, 1x3, and 1x4 pieces. There will be a certain confidence interval depending on which element the model believes is being seen. If it does not meet a certain confidence threshold, that means we haven't categorized that element yet. A bunch coming through, and we can see how the channel is actually working really well here. Okay, 2 things are going on in the Python code. One, it has a list of all of the elements, as well as the positions of the servo. Now, eventually, when a larger model is able to be trained, the plan would be to implement many more different categories, as well as when you can identify an individual piece, you can also create essentially folders for these elements to be sorted into. Alright, so unfortunately the table just broke, but as we can see for proof of concept, the 1x1 elements were placed in this cup. The 1x2s were spilled out mostly, but for the most part it did a pretty decent job.